So, I actually still remember the first time I saw a picture of a T-Rex in one of those books I used to read when I was still in elementary school. And well, naturally, for pretty much everyone who sees a picture of a T-Rex, the first question that comes to mind is, okay, why exactly do they have such tiny arms? How can you have such a scary giant with such a comically small arm that looks like nothing we have today in any of the animals? And though in the last few decades there's actually been quite a few explanations and potential propositions, today we're going to discuss one study that seems to have solved this mystery once and for all. And well, hello wonderful person, this is Anton. Today we're going to discuss some of the recent studies about T-Rex, one of the most misunderstood animals to ever walk on the planet, that, as you probably know from the movies, has always been described as this king of the tyrant lizards. And that's actually what the name means, Tyrannosaurus rex. Yet, based on some of these recent studies, they actually seem to paint a slightly different picture of an animal that was way more complex and that potentially lived and even looked a little bit different from how we imagined it in various movies like the Jurassic Park. And so let's talk about some of these recent studies from the last few years, starting with this most recent one that solves the mystery of its tiny arms. And so why were they so tiny? Well, for a very long time, paleontologists believed that these two-finger limbs were kind of an evolutionary leftover, or possibly even some kind of a vestigial mistake similar to our appendix. And the thing is, as you might have learned from one of the recent videos, apparently we were even kind of incorrect about our own appendix, because it turns out that it's not as useless as we initially thought. You can learn about this in one of the videos in the description. Which is to some extent is a very similar conclusion in this study by Charlie Roger Scherer, Elizabeth Steele, and Paul Upchurch. Here, by analyzing 82 different species of this meat-eating dinosaur, the conclusion is that it was unlikely to be some kind of an accident, and instead was a very typical evolutionary trade-off that we've actually seen in many animals many times. And especially because, apparently, multiple groups of these two-legged predatory dinosaurs independently evolved these tiny vestigial arms, suggesting that something a little bit more complex was going on here. And so here the study solves this mystery by finding correlations between the skull size in these animals and what they seem to hunt. In other words, they do discover the exact reason. And so out of these 82 species, and by using a system involving what's known as a cranial robusticity scoring system, or basically a system that scores how solid and how strong the skull of the dinosaur was, mostly focusing on the bite force and the overall strength of the bones, they actually found a direct correlation. Here, the shrinking arms seem to be strongly and directly correlated with both gigantism, or the overall large size of the predator, and, importantly, the strength of their skull. Here it's referred to as cranial robusticity. So basically skulls that were larger, heavier, and more rigid seem to directly correlate with smaller arms. And this was not a one-time fluke. It apparently happened across 5 distinct lineages and resulted in exactly the same appearance. In other words, this was an example of what's known as convergent evolution, with the most extreme arm reduction seen in 3 major apex predator families. The first one was obviously the T-Rex, but this also happened in Abelisaurids, as you can see here, it barely has any arms, and Carcharodontosaurids, such as the famous Gigantosaurus. And so despite similarity in appearance, they were actually entirely different species and were not directly related to each other. And the reason they kind of look the same is basically the same reason why we have so many different animals evolving into crabs. And that's because back when they were alive, there was an evolutionary advantage to have a large body size and a powerful skull. And this seems to have been historically driven by the type of available prey, specifically massive sauropods and ceratopsians. Or in other words, in order to hunt something like this, you had to have something incredibly strong, because nothing else would take these animals down. And so here the study concludes that as a lot of the prey grew larger, the overall hunting strategy underwent a massive functional shift. Instead of relying on grasping forelimbs, something that, for example, velociraptors have in order to grab their prey, and instead of relying on sharp claws, these dinosaurs evolved a highly robust skull capable of delivering bone-crushing, powerful bites. And because the head and the jaw became the primary highly optimized weapon, the selective pressure to maintain large, energetically costly arms dropped completely. In other words, having these large arms was completely useless, and probably even got in their way because they were mostly relying on skulls to do all of the hunting and, of course, eating. And so over time, there was a functional shift, causing the arms to reduce in size across multiple unrelated lines of giant predatory dinosaurs. Once again, same reason we have so many animals evolving into crabs, with the T-Rex actually ranking highest in skull robustness amongst all species studied, which means that it does deserve its T-Rex name after all. It is the king of dinosaurs. But this was just the first discovery explaining one of the mysteries. Here we actually had a few additional studies that were not just about bones, but also about studies on molecular biology of T-Rex and even its blood and healing. And one of the most surprising discoveries involved a T-Rex nicknamed Scotty. This was from a different study from 2025, and it was also from the largest T-Rex specimen ever found. And so here, by using specialized synchrotron X-rays, researchers were able to peer inside this specimen and actually discovered a network of preserved blood vessels that was hidden inside the fossil. And these were not just impressions, they actually seemed to be iron-rich, mineralized casts that used to be specialized vessels working to heal the bone while Scotty was still alive. Which actually tells us that T-Rex seemed to have active healing process that seems to be extremely similar to modern birds. And that means that it potentially could survive massive injuries that would have killed other animals. In other words, just like certain modern birds, it was able to heal extremely quickly and was able to repair itself, which was obviously beneficial for its lifestyle involving large prey and a lot of fighting. Then there was also a study in regards to its appearance, and specifically its face. Because if you actually look at most museum displays, or obviously movies, T-Rex is always presented as this terrifying beast with teeth sticking out, similar to a crocodile. But a major study from a couple of years back suggests that this is likely incorrect, and suggests that T-Rex, specifically its face, potentially looked like this. And this was discovered by comparing the wear on the teeth of a T-Rex to those of living reptiles such as crocodiles and alligators, with scientists discovering that T-Rex's teeth seem to be surprisingly well preserved. And while, for example, in crocodiles, because the teeth are exposed, they also often get damaged and worn down by a lot of activity in the environment. And that's because they don't have lips to protect teeth, and so teeth get damaged much quicker. But in comparison, T-Rex teeth seem to show much less wear and seem to suggest that they were potentially hydrated and protected behind some kind of a lizard-like lips. Which basically means that the T-Rex we see in the movies is potentially incorrect. Its mouth was very likely closed, and its teeth would likely stay hidden when its mouth was closed. And so only when it opens its mouth, you finally get to see these terrifying blade-like teeth, with this being the most likely representation. Then we also have some discoveries in regards to its origin in terms of the actual continent. So we have new clues about its origins. And while previously scientists believed that it migrated to North America from Asia, based on this recent study from March of 2026, this seems to be not the case. And that's because a 74-million-year-old bone was now discovered in New Mexico that seems to predate the classical T-Rex by several million years. And this seems to be a bone from a possible ancestor that now suggests T-Rex very likely evolved in the American Southwest and was possibly already gigantic several million years before T-Rex became the dominant species. Although interestingly here, a completely separate study also solves the mystery of a slightly smaller specimen that was previously believed to be a teenage T-Rex, but that some scientists refer to as Nanotyrannus. And that's because for years scientists believed that Nanotyrannus was basically a teenage T-Rex, existing because T-Rexes used to grow extremely slowly, and basically some of them perished as teenagers. And it's actually interesting because one of the most exciting specimens discovered of this dinosaur is part of the dueling dinosaurs. This was found in Montana, with the other fossil being a Triceratops. But a recent 2025 study, mostly focusing on the dueling dinosaur specimen, now provided evidence that Nanotyrannus was actually a completely separate species after all. And this was discovered by looking at the growth rings inside the bones, which revealed that they were fully grown adults, in this case at least 20 years old, and not juveniles or teenagers as previously assumed. And this suggests that T-Rex very likely shared the environment with its smaller, faster cousin that seemed to rely on a slightly different hunting strategy. Kind of like similar to how lions share their environment with the faster and more agile cousins, leopards. And so definitely quite a few intriguing discoveries. But why do we even spend so much time studying all of this? And specifically, why study these scary giants? Well, this is not just about curiosity, because here, this also tells us about the limits of biology. And so, for example, by understanding how T-Rex moved, healed, and evolved, we also indirectly learn about how life seems to respond to different extreme environments and extreme types of competition, because it's very similar to what we see today in a lot of different species. And as a result, what we have here is an almost perfect predator, a creature with binocular vision much better than a hawk, a sense of smell rivaling a vulture, and even a brain that was surprisingly large for its size, most likely implying complex behavior. So this was not some kind of a mindless killer with very poor vision, as we were told in the Jurassic Park, and instead was a very sophisticated, highly adapted success story that ruled the terrestrial surface for millions of years. And it might have been even ruling today if it wasn't for that unfortunate accident involving a space rock. You can learn about that in some of the videos in the description. And so on that note, at least for now, that's all we know about this somewhat bizarre, lipped, highly intelligent, and highly efficient predator that ruled the planet for several million years. And once we discover something else, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.